way. Okay. So our function is cosine squared minus cosine, and we are interested between 0 and 3 pi over 2. Find the max value and the min value. So I know that's extreme value theorem, which tells me to test the endpoints, which they gave to me, 0 to 3 pi over 2, and any of the critical numbers, which they didn't give to me, so I have to go and seek those out. So critical numbers are when the first derivative is 0 or undefined. Now, I anticipate that for a lot of you guys that missed this one, it's probably this part of the derivative. And we talked about this quite a bit in Unit 2, but it's not something we practice on a regular basis. Cosine squared, when we square and cube and raise trig functions to an exponent, we like to write it like this. It's just a notation that we use. But what it really means is you've got cosine squared. So the first part of this derivative is power rule. Bring the power down, lower the power by 1, and then there's a chain rule step. The derivative of the inside is negative sine. The alternative, to me, I think this is always preferable. Power rule is just so easy. But if you were not sure how to deal with that, you could change cosine squared into cosine times cosine, do the product rule, and you would see that you got that same piece there. So I'm expecting that that's probably a lot of the mistakes was that part. Then the derivative of cosine is negative sine, so that changes that to a plus. And if I'm trying to find critical numbers, I want to know where this is 0 or undefined. Now, sine and cosine are never undefined, so it's really just where does this equal 0. And you could factor out a GCF of sine. And then some of your critical numbers will be where sine is 0, like 0 and pi. And then some of them will be where cosine is a half, which is pi over 3 and 5 pi over 3. But I did not include 5 pi over 3 because that's not between 0 and 3 pi over 2. It's not in the restricted domain that they want me to work with. So there was 3 critical numbers, 2 endpoints, and then I started plugging those into the function. You plug 0 in up here, you get 1 minus 1. Plug in 3 pi over 2, you get 0 minus 0. You plug in, oh, I don't need to do 0 twice. If I already plugged in 0 once, I don't need to plug it in twice. You're going to get the same value. So if I plug in pi, I got 1 minus negative 1. And when I plug in pi over 3, I got a half squared, which is a fourth, minus a half. So a fourth minus a half is negative a fourth. Got to be extra careful with the arithmetic. So the absolute max was 2, because that's the biggest number sitting here, and the absolute min is negative 1/4. And I know I don't need to test any other x values because this is what extreme value theorem says. If you know which candidates to test, the endpoints and the critical numbers, then your absolute max and min are guaranteed to be sitting there waiting for you in the table. But again, the derivative of cosine squared, that's a very common thing. Make sure that you think of it as cosine squared with parentheses and start with power rule, or write it as cosine times cosine and do product rule. Whatever you think you're going to be more reliable on. Okay, Lucas, had enough? Okay, anybody else going to ask about 9 while it's still up there?